This is a basic overview of the calipers and brake setup on the front wheels. From the back, from the wall of the car, you've got the flexible line which goes to a connection back here at that bracket, which is bolted to the steering knuckle. Then there's a hard line that goes to the caliper itself, which is why we need to remove this single M6 screw here, so this bracket here, which holds onto everything including that hard line, can come free, and then that will allow us to remove the caliper later. But that single line comes into the inward side of the caliper, and it'll have either 2 or 3 pistons on each side. And then there's another line which comes from the bottom here to the other side. Again, you're gonna have 2 or 3 pistons on the other side. Inside here, there are the brake pads, and because we have the support pieces on the back here, the brake pads on these can't come out rearwards. We need to remove the entire brake caliper to get access to the brake pads inside. And in addition to that, we have this thing here, which is the anti-rattle clip. Also probably noticed that I don't have the wear indicator sensor, which goes in here and connects to the pad itself on the inside. On the rears, it's on both sides. On the fronts, it's only on that inside pad. It would normally come out of here, go through this slot here where it's held in place, and then it would go through a clip back here on the hard line prior to going to the connector just there. I've actually cut that off, and the reason for that is because these had already worn through and the warnings were making me go nuts. So I just cut it off back here and just joined the wires together so the system thinks that the brake pads are okay and made those warnings go away. But clearly you don't want to be doing that to your own car. You want those wear sensors working for you to tell you when the brake pads are getting too worn. To bleed the brakes, unlike a floating caliper, we have 2 points where we can bleed the brakes. So we pop off these rubber covers over the top, put a hose on that, unscrew these, and then when we push fluid through here, it pushes it all out, all the air, etc., and all the old fluid out. So you need to do the inside first and then the outside, but there are 2 bleeding points on both sides. On the front brakes, before we remove the caliper, I need to disconnect this metal bracket here, which holds onto a number of electrical connectors, as well as the hard brake line, which goes down the back. And I also want to disconnect the wheel speed sensor here. For the bracket, just a single screw there that just removed, and then that comes loose. That takes 10 Newton meters when you install. For the wheel speed sensor, to disconnect this, because this has been out in the weather for a little while, probably just want to give it a bit of a wiggle to start off with, but then push it down, get a screwdriver and lift that up like that, and then it comes off. So to open up the brake pads a little bit so you can get the caliper off and over the lip on the rotor itself, just get a screwdriver down each end, so you don't need to be putting it on the pad. There's a gap down the bottom here in between the backing plate of the pad and the rotor itself, and then we can just lever those out and they just push out as all it's doing is forcing the fluid in the pistons here as it's compressing those pistons in and just forcing it back into the reservoir underneath the front hood. And so you can open those out as much as you like on both sides, and that will actually make it pretty simple to remove the caliper once we've done that. To remove the caliper from here, once we've opened those out, there are 2 bolts here. They take a 10mm Allen key. When you install those, 85 Newton meters is what you need on those. And then once they are removed, this thing will just be sitting there jiggling around, and then we can put that up and hold it up. Prior to removing the caliper, have something ready to support this, because you don't want to put the brake caliper's weight on the line, especially because of this hard line here that could easily get bent. So you need to be a bit careful with that. This has got a hook on the end, which is just going to go on to the spring on the strut and the end. Long straight bit, it's going to go through the hole when I remove the bolt, and then I'm just going to turn that up to hold onto it. And what I'd prefer it to, having played with this a little bit, is to have it a little bit lower, and the reason for that is the hard line here gets pretty close in this little gap where the sway bar link is. You're better off having it a little bit lower, and then it's more easily able to be moved, so you can work on things, because you're going to be moving this a fair bit to get the brake pads, etc. out. So remove that bolt. Stick it through there, over the spring, and then I'm just going to bend that up like that so there's no way then that come off. And now I can actually move this quite happily here with a lot of freedom to do what I need to. Removing the pads now is made more difficult because at the back here you've got the anti-rattle clip, and it's pushing hard against the outside of the pad. So probably the easiest way to do this is to get your fingers from the back in here, and doing these one at a time, and I'll do this one here first. I'm going to pull out and I'm going to push that way, and that should help out taking the pressure off the back here to allow those to come out. Now I've actually pulled these out and I'll put grease on them, etc., which is what you're going to do and install, which has made those come out a little bit more easily. But normally what would happen is that you push one end off, that'll rotate out like that, and then you can push the other end off and it should come out okay. You'll notice in here we've got the wear sensor on that inside pad, so we're going to remove the pad like I just did for the other side, but then because that cord at the other side is disconnected, it will allow it to come through that hole, and then we can just pull that out once we get the pad out itself. So again, pulling out on the inside, pulling out one side first, this is what it's more normally like, and then it'll rotate that way, and then it'll come out, and then there's your anti-wear, your wear indicator sensor, and you can just get a little screwdriver in there and just lever that out, and that'll pop straight out. And then once that's there, they can get fed through the other side. And prior to installing new pads, a couple of things I do. Firstly, just get your fingers in here and just compress all those pistons. They should be able to easily compress by hand. You might have to do them a couple at a time and just do it over and over again, because it will compress or it'll push out the ones on the other side because of the pressure inside, but you need those all the way in. You could use G-clamps just to push those in, or there are spreaders that you can buy, which I've got in the shed, but I actually just find doing it by hand is probably easiest. But you want those all the way in. What you also want to do is clean everything up. So get some brake cleaner on here, and then compressed air, blow all the old dust and that sort of stuff off it. You want to look at the boots around, because there's rubber boots around each of those pistons, and check that they are in good condition, there's no damage. And then what I'm going to do is, prior to putting in the new pads, I'm going to grease up the contact points. So the contact points on each side are going to be where the anti-rattle clip touches the back of the pads there and there. I've got the pins that actually hold, that guide the pads themselves. I'm going to grease those up, and also the surfaces that contact on the pistons themselves. Now some people will just cover this whole thing in grease. I'm not a big fan of that. You can see where the contact points are. There's actually not that much, and if you just put grease on the inside here, that's going to stop any squeaks and that sort of thing later on. The grease that I use is this stuff here, which is specifically for this sort of application. It's not standard grease that you're going to put on your bearings and that sort of thing. This is good. It says extreme temperatures up to 1650 degrees Celsius, which is the stuff that you want. Normal grease melts far, far lower temperature than that. Also, one of the nice things about putting it on here instead of on the brake pads is that I find there's much less chance of getting, when you're moving with your hands and stuff, getting grease on the contact surface of either the rotor or the brake pad. And that is clearly something that you want to avoid, because grease on those contact surfaces stops your brakes from working. So that's another reason why I do it that way. So for the install, first thing you want to do is push the new cord, or the old one if it hasn't worn out, for the pads wear sensor through the back here, and then you're going to just push it straight into here. They just plonk straight in. And then once you've got that in there and it's just sort of sitting there like that, you grab it at the back, feed it through. And then I found the best way to actually put these on is put in one at a time. So I find the top one first, and then we're going to rotate it down. And then when I get to here, I'm going to get my fingers underneath and pull back on that anti-rattle clip, and then it'll just push straight into place. And that way there you can see your fingers are going nowhere near the contact surfaces, and so you shouldn't get any grease anywhere where you don't want it to be. Here's that brake pad wear sensor when it's in place. On a new one, the sensor itself would only be about that width, whereas the brake pad would be out there somewhere. To remove those, you can just get a screwdriver in there and they will pop out like that. And then for a new one, and it could be the old one if it hasn't actually worn through yet, you just get that and just push that into place. And you want to do that obviously after you feed it through the back of the caliper. To remove the rotor, the first thing that needs to happen is we need to remove these two screws here. Now these are unusual in that they've got a Phillips fitting and they've got 10 Newton meters on them, which is kind of interesting, and you hear of people burring these over all the time. Other brakes that I've worked on have Allen keys, which work much better, but these are much smaller screws, so maybe that's why they've gone down that path. I would advocate using a gadget like this to get these off, especially if you're struggling to get them to move. These things are designed so that you put the bit in here, and when you hit them with a hammer, it then initially loosens it. So they are actually really good for a job like this. So put that in there like that. Turn it in the direction where you want it to go, because it can be either trying to put it on or put it off, and then you're just going to give it a quick tap like that, and now we should be able to just turn that off like that. And prior to removing those completely, my advice would be to pull them halfway out, and I've removed this before so everything's nice and loose, but you could have the rotors seized on there. And so what you want to do is whack these off with a hammer or a mallet and a piece of wood, but still have these connected so they're out a few turns, so it still just hangs there like this, rather than the thing just falling off, hitting the floor. But once they are, the rotor is loose, then we can just remove that. And the rotor will come off. You'll notice also that I've got lots of anti-seize paste on everything. I would advocate putting some of that on these screws when you install it again, as well as on the faces here, the contact surface with the wheels, because they get seized on really easily, as well as the bit around here where you have this interference fit on the hub, and then as well as that on the inside here. So this is obviously the hub itself. When you've got this off, you need to clean all this up, get a wire brush onto it, compressed air, and again I would advocate putting some copper anti-seize paste on all of that prior to installing again. And for installation, it's pretty simple. We're just going to align those two holes, put that on, put those screws in. Now whilst the book says put 10 Newton meters on these, and if you've got a bit like that, that takes an 8mm socket, so I could quite happily put 10 Newton meters on that. It's not that essential. As long as these are pushed in hard enough so they are flush with the hub, that's all you're really after. Because when you put the wheel on and put the wheel studs in, they're actually going through the rotor and going onto the hub behind. So it's actually clamping the rotor itself in between all of that. But if you can put 10 Newton meters on it, then go right ahead. With the pad and the rotor, when they wear, the rotor itself won't wear all the way to the edges, and you'll end up with this lip on the end because the pad itself is slightly narrower, and you end up with this sort of railway line thing happening. You can see on this rotor and the pad that there are ridges that have been worn into it. If I was replacing these pads and I saw this on the rotors, even if these were inside thickness spec, I would be replacing the rotor as well, because clearly the contact surface when you put the new pads on is going to be pretty poor. But you can check the width of the rotor itself just using some basic calipers. The problem is that we need to sort of measure inside here. So if I zero that out, I can see the width at the start was about 28 mil. And what I can do is if I just use something that's a little bit thicker than the lip that's on the edge there, I've just got a couple of big pop sticks there. I'm just going to use one on either side, and if I just do that, zero that, and then I put that on that side like that, and now measure, that'll give me the actual thickness. So it's gone down to 25.85, so it's worn a little bit more than 3 millimeters total, so a little bit over 1.5 mil off each side. So you'd have to have a look at the spec for your rotors and work out whether, firstly, that was inside spec. If you saw damage like this and it was still well within spec, you could have these shaved back so they're nice and clean, but again, only you can make that decision. But if I saw this, I'd just be replacing the rotors. These are the bolts that hold on the brake caliper. The one on the right is for the rears, one on the left is for the front. There is some debate as to whether or not you need to replace these or not. I don't. Everybody can make their own decision, but I don't, and the reason for that is because these are an M12 bolt. Standard tightening specs for an M12 bolt are about 80 newton meters for a class 8.8 and about 110 newton meters for a class 10.9. Now, the markings on these, I can't tell what they are, but having only 85 newton meters on them, they are going to be well within the elastic capabilities of the bolt, regardless of whether or not they're a class 8.8 or a 10.9. So I'm more than happy to reuse them. They're not torque to yield, so they're never going to get stressed beyond their elastic point and do permanent deformation to the bolt, so I have no problems with it. I would, however, be looking at the quality of the bolt when you pull it out, check that there's no corrosion, because on the inside here where it joins onto the knuckle, especially at the front, it's open, so water can come in from the inside, etc. And also I'd be checking the holes and the threads where it actually goes into on the knuckle. Here is a basic overview of the rear brakes. We have a single fixed caliper similar to the front, albeit smaller because the rear brakes are always going to be smaller than the fronts. Two big screws that hold the caliper to the axle. Like the fronts, we have the wear sensor, albeit on this one we have two, one on each of the pads. We have a hard brake fluid line at the back here, which connects at the back to a flexible line and a bracket that holds onto that, which can be disconnected and loosened by a single screw up the top. We also have the wheel speed sensor back here, and if we're going to remove this bracket here, that needs to come off because it's connected to that bracket at the back there. We have two bleeder points, the same as the fronts, one on each side, and the line that goes from one side to the other side. To remove the brake pads, the first thing I need to do is disconnect the wear sensor plug. It's going to be jammed inside here and on this metal bracket here, so it's a bit of a pain to get off because it's a bit of a tight fit, but wiggle that, and also it'll have a bunch of dirt and crap in there for a while, you know, underneath the car, so you'll need to persevere with that. You can just pull that out of that little gap in the caliper where that's going to be removed. Prior to moving anything, what I want to do is push these out. So I can just get a screwdriver in here and then just lever these out a little bit so they're pushed out like that. Now I've moved these out already, but you want to push those out so they're a little bit wider because there'll be a lip most likely on the rotor, which you'll need to get it around. So you need to move it out maybe a mil or two. And then from there, I can remove this little, they call them an E-clip at the back. That just pops straight out. And that's the thing that's stopping this pin from holding or from moving. And then I can push that pin out. And all I'm going to do is just hit that with a screwdriver and a hammer and just gently tap that out. And once that's loose, I need to disconnect that. There's a little clip there that holds onto the wire for the anti-rattle clip. I can remove the anti-rattle clip out of the way. And then, once I move that pin out, now the brake pads just come straight out with the wiring. On your new pads, when you're installing, and obviously these aren't new, the contact points, I'm going to put that ceramic grease on, that brake grease. So what are the contact points? You can see the notches that come out of there and there. They slot, there are pins in behind here that it actually rides on. So when it's in there, it's a little hard to see, but in there is that circular portion of the pads. So based on that, I'm going to be putting a small amount of grease, and you can actually see some corrosion there, which is from the contact with the pin there and there on both of those. In addition to that, the parts that are going to be contact points on the clip are just along here. So I'm going to put a bit of grease there. And also, I'm just going to put some light grease all the way along the pin. It's going to help it go back in as well, because it slots through the pads at the back of them, of the backing plate, as well as it's going to need a little bit in the middle there as the contact point on the clip. If you're putting in new pads, you may need to get a clamp, a G-clamp or something in here, and compress the pistons, or you can use a tool, and I'll show you the one that I've got. Prior to installing, have a good look in here. I'd get some brake cleaner and then compressed air and blow all the gunk out, make sure all the seals, etc. in there, there's no cracks and everything's looking fine. And then we can install our pads. These are obviously the old ones, but I'll put grease in those contact points like I talked about before. My anti-rattle clip, that's going to go in there. And once the anti-rattle clip is in there, I can have that clipped in there. I can push that through the hole for those wires. When I install the pin, have a look for where the hole is. Make sure it's pointing out, because I'm going to put that locking pin in from the top when it gets in place. Where is it? There we go. And then making sure it goes underneath the wire, and then I'm going to push the rattle clip down and then just push that all the way home like that, and then I'm going to fit that pin. There we go. Removal of the rotor. Ensure you've got the park brake off, or you're not going to be able to get the thing off if the park brake is on, because it'll be expanded out onto the inside of the hub of the rotor. And then I need to remove these two Phillips head screws. They've got 10 Newton meters on them. Like the fronts, I'd be using a tool like this, where I just put this in there and give it a whack, and that's going to hold it in place. I've already removed these, and again, might be seized on a little bit at the back. So I would suggest half removing these, and if it doesn't come free like this one is, then I would be getting a mallet and a piece of wood onto the inside to give it a bit of a thump until it's loose, and then once it's loose, then remove the screws out of it. And then with those two screws removed, the rotor will come off. So obviously the hub there, and there are the park brake shoes at the back there. And the install of the rear rotor is exactly the same as the front. Make sure that the park brake shoes are centralised. You may have bumped those, they can move pretty easily, so just centralise those by hand. I would suggest putting some copper anti-seize paste on the hub here. And then we are going to put the rotor on there. The two screws will go in there, they get 10 Newton meters. And so here is my basic setup I'm going to do this at all four wheels. It doesn't matter which one that you're starting from. I'm going to make sure that I've topped this up with new fluid. I've got my bottle connected with that hose. I'm going to start at the inside of the 2 bleeder valves, and then I'm going to pump the brake pedal until this starts to lower down. If it starts to get down to about here somewhere, I'll fill it back up again. Then I want to pump until I get nice clean fluid out of here. Then I can shut this one off, fit it to the other side and repeat, and then just go around all 4 wheels. So this is the bottle that has all the old brake fluid pumped into it. It's just a soft drink bottle with a hose, which is clear plastic, which you get from the local hardware store, 5mm inside diameter, and that'll fit over the nipple of the bleeder valve really nicely and keep it nice and sealed. I've got a hole drilled in the cap here alongside where the hose goes in so air can escape. And what the aim of this is, and it works really, really nicely, is the fluid's obviously going to get pumped into the bottle, but the bottom of this tube goes all the way down to the bottom of the bottle. And the reason for that is when it starts to fill from the bottom, you want the bottom of that hose, that end of it, immersed in fluid, because when you release the pedal, it's going to try and suck fluid back into it, and what you don't want is to have any air in that. You want this whole thing to be full of fluid, so it only ever comes back with air-free fluid rather than stuff that might have some bubbles in it. To start the bleeding process and connect your hoses to these, we're going to start at the inside one first. You can just lever off the top of that rubber cap like I've done there. It's just got a little connecting piece there. We're going to leave in place, and I'll show you on this outside one first because there's better light here. 11mm ring spanner, I'm going to fit that over there first, put the hose over the top of that, and then I'm going to release it. And you only need to turn it about maybe 1/4 of a turn, which is going to allow plenty of fluid to come out. And then once you finish the bleeding process, that spanner will still be in place. Then you can turn that back, tighten it, and then you can remove the hose afterwards. So once you get nice clear fluid through here, you can tighten that off, take the spanner away, and then just so you don't get loads of fluid going everywhere, if you sort of just gently with it and then put it so it points up, it'll just fill up with air and you don't end up with leaking fluid all over your calipers. Something to be aware of with the reservoir, it's divided internally into a number of chambers. It looks like there's 4 of them. The rear one is for the rear piston on the master cylinder, which I think goes to the front brakes, and up the front here is to the rear brakes. Problem is that if you try and get a bit cute and try and pump out as much of the dirty fluid before you start to add new fluid into it, just so you don't mix too much new with the bad old fluid, so you don't go through too much before you get all that good fluid coming out the other end, is that once it gets down to about that level there, that's the top of the baffle there, and then, for example, if you were pumping out the front brakes, this will just go and just rapidly lower, and you'll start pumping air into it pretty quickly. So be careful of that. I would advocate not getting below about that level there prior to filling it up again. It'll rapidly get out all of the old fluid. You might use a little bit of extra, but it's not such a big deal. Certainly a far better option than possibly getting the air into the system. If you want to remove the filter that's in here to suck fluid out, either just to make it easier at the start or you've overfilled the thing, then it's pretty simple to remove. It's sort of jammed in there on some clips down the bottom, but if you just get some long nose pliers, put them down the side like that, and then just give it a tug, that'll just pop straight out. So here is my setup at the reservoir end. I've removed the filter from the inside of the filler neck because I find that with the filter in there, it really restricts the amount of fluid that I can pour in there. It's really easy to overflow it. Also use a funnel, especially when you're starting off with a new bottle. It's going to be easy to spill fluid everywhere if you don't use a funnel. So that's what I do. Make sure obviously that is perfectly clean before you start to use it. And then what I'll do is I'll fill it up with fluid. I will go into the cabin and I'll actually stand outside the cabin with 1 foot in so I can watch this as I start to press the pedal with one of the brake bleeder lines open to watch the level of this. I'll have a torch at the back here. I'll just put that on there, just so I can see much more easily the level of the fluid, because when it's dirty and old, it's dead simple, but as soon as you start to fill this with clean fluid, it's quite hard to see the level of it. And what you don't want to do is obviously allow it to get too low and to push air into the system. Also of note, you've probably seen the colour of this brake fluid. That's shocking. That is really, really dark. General spec is to change this every 2 years, and over 2 years it should not change colour by very much at all. It's a really light honey colour when you first put the stuff in, and as it gets older it goes darker and darker. I suspect that this is, I don't think it'll be the original fluid, but geez, it'd have to be pretty close. So this is obviously going to get changed. With brake fluid, it's not an oil, it's actually water soluble, and generally, certainly .4 I think is glycol based. And the reason I use that is because it's non-corrosive and it has a very high boiling point. The problem is when it starts to get old like this, it actually soaks up water from the atmosphere, which is why the system is completely closed, but it still will get water in there. And the problem is that when things get really hot on the back of the brake calipers, and they will get properly hot, especially under high loads on the track or going down a big hill, what happens is the water boils and you get bubbles in it and your brakes go, because instead of having an incompressible fluid inside, you now have bubbles of water vapor which can be compressed easily and your brakes stop working. So it's important to change this fluid regularly. Every 2 years, as I said, is the spec. But certainly if it starts to get dark like this, you want to get new stuff in there. And here is what is coming out of the brake system. Definitely want to get rid of that stuff. Once the rear rotor is removed, you can see the park brake system. It's a pretty bog standard park brake system, the way they've been working for many years on many makes, except for the fact that on the back we have the electric actuator. So the actuation is done by an electric motor, which goes to the electric park brake control module, which sits in the rear boot on the right hand side. So instead of having cables actuate it, it has the motor do the work. And the way this fits together is on this side over here. There is a manual adjuster which sets the spacing in between the two shoes, the top and the bottom one. That's set in the factory and you generally shouldn't have to touch that. And then the shoes themselves are held in place. They're actually held to the bits behind it by, there's a spring here, top and bottom for each one of those. And there are springs that hold the two shoes together. There's one at the front here and there's one at the back there. So to pull all this apart, you are going to remove the two springs, front and rear. And then you can remove the manual actuator at the back. Then we can remove these springs here which hold on the shoes, and then the whole thing comes off. And if we want to remove the actuator itself, maybe it's broken, then there are two screws here that can come out and this thing slides out this way once you disconnect it from the electrical connections and this clip here at the back. For actuation, this thing in here expands and contracts. So when it expands, it's going to push the shoes outwards and that's going to clamp on the inside of the rear rotor. And when it contracts, obviously, it allows that to move. This is the adjuster unit at the back, which is set and leave, and this is done at the factory. And unless you are changing over the shoes, you really should not have to adjust this, or you're somehow doing handbrake turn-ins, you're really wearing the thing out and it needs to be adjusted. But all that happens is that this bit here, which has got all the ridges in it, is threaded into that spot there, and as we turn it, it's going to either expand or contract. And then the idea of it is you can have the wheel off but the brake rotor on. You align the hole here and you just go in here and then you just do these clicks. If you are removing this, I would suggest marking with a paint pen like I've done there, So when you pull it apart, because this bottom bit here will just fall straight off, that doesn't really matter, but it's that in relation to the top bit there that's important, which sets the gap. So if you're pulling this all off and putting it all back on again because you are changing wheel bearings or whatever, then everything goes back on okay. The workshop manual talks about when you get this off, just getting a cable tie and tying the thing together. You can go ahead and do that if you like, not really required, as long as you mark the position, that's kind of important. Removing this spring, because there's one at the front and one at the back that need to be removed prior to moving the brake shoes. This one's got a fair bit of force on it, and the way that I would suggest doing this is just getting a screwdriver under there, lifting that out, and then that'll enable you to get a pick tool underneath there, and then you can hold onto this and then pull down hard, and this thing will actually pop out. They're pretty hard. And to get this back on, hook it on the top one first, get your hook tool underneath it, and then put it on here and pull it all the way down. There's a fair bit of force on it. Then you'll have to push into place. It might just sit on the lip there, and then you'll have to get a screwdriver or a pair of pliers and push it into the hole. The one at the front here is far simpler. You just get your pick tool under there and that'll just pop straight off, and putting it back on is pretty much the same. Removing these springs that sit in here and hold the shoes in place is a bit of a pain in the bum, to be perfectly honest. The way these work, so obviously the shoe would be sitting in like that. That goes through the hole and it hooks into this hole at the back here like that. And what you need to do is compress it and then move it sideways. The workshop manual talks about moving it clockwise, and to be honest, I don't know why they say that, because that doesn't really work. And when you actually look behind here, it doesn't make a whole bunch of sense to do that. What you actually want to do is, if you look at the shape of that, there's this bit that curls around, and the side that this thing comes in on is the side that this hook is on. So what you need to do is, when that's in there and hooked behind it like that, because it would be holding on, you need to compress that really hard and move it away from that bit of spring that's going down that way. So you would push it in and move it sideways, and then that will allow it to actually come out of the hole. To do that is a bit hard. This is the tool that I was using. They're just some narrow vice grips, so I could get hold of that and then push it. You need to push it in all the way in as hard as you can, and then what I was using was a screwdriver to put it on the side here. I'd worked out the orientation of where that hook was going to be at the back. You can see where that easily from this side. And then as you push it in, then push it sideways. And then after much perseverance, it came out. But that's probably the hardest bit of the whole process.